Hey folks, how's it going? Mr. Mitchell here. In this video we're going to go over section 1, i.e. the multiple choice questions from the 2016 SQA National 5 Physics exam paper. Now there are 20 questions in this section and I recommend that you try them yourself before looking at these solutions. So let's get into it. Question 1 says that the symbol for an electronic component is shown. This is the symbol for an LDR, a transistor, an LED, a photovoltaic cell or a thermistor. Well, first of all, notice that you've got a diode shape, this little triangle with a line, which means that current only flows through this device in one direction, and you've got two arrows going out of it. Now, you simply just need to know your circuit symbols for different components, and you should remember that this one is the LED, the light emitting diode. Now, the way to remember that is that these two arrows represent light going out of the diode, so therefore, if you know that this is a diode and this represents light, then it's got to be something that emits light. So the only thing that does emit light here is the LED, because remember the photovoltaic cell, that is something that takes in light to produce a voltage, and the LDR also takes in light because the light dependent resistor is a resistor that depends on light. So the answer has got to be C, an LED. Question 2 says that a uniform electric field exists between plates Q and R. The diagram shows the path taken by a particle as it passes through the field. So we've got plates Q and R here, and we've got point P here moving in a straight line until it reaches the plates, at which point it starts curving up towards plate Q. It then says which row in the table identifies the charge in the particle, the charge in plate Q, and the charge in plate R. So here we need to find the right combination of charges on the plates and charge in the particle for it to make sense. So in order for the particle P to be curving up towards plate Q, the particle P must have the opposite sign to plate Q, and it must have the same sign as plate R. And that's because the particle of a certain charge will be attracted towards a plate of opposite charge and repelled away from a plate of the same charge, because like charges repel and opposite charges attract. So let's look at the first column, the charge in the particle, and the last column, the charge in plate R, and see which ones have the same charge and therefore could be the answers. So A is negative and negative, which could be it. We've got negative and positive for B, so that's not going to be an option. C, no charge and positive, that's not going to be an option. No charge and negative, also not an option. And E, positive and negative, that's also not an option. So that means we've got our answer. We've got the answer, which is option A. So we've got the same charges on the particle and plate R and the opposite charge on plate Q. Question 3 says that a circuit is set up as shown. So we've got two cells creating a battery, we've got ammeter A1 in series with the battery, we've then got two resistors in parallel next to two resistors in parallel, and each of those has their own ammeter in series. Then says the reading on ammeter A1 is 5.0 amps, the reading on ammeter A2 is 2.0 amps, and the reading on ammeter A4 is 1.0 amps. It then says which row in the table shows the reading on ammeters A3 and A5. Well, let's look back at the picture and let's label on what we know from the question here. So the reading on ammeter A1 is 5.0 amps, on A2 it was 2.0 amps, and on A4 was 1.0 amps. Now remember, current in a parallel circuit will split up through the branches. So we have 5 amps passing through the battery, which will go from the negative terminal here to the positive terminal of this battery here. But when the current reaches here, it's going to split up through the branches along here and then meet back up here and then split up again here and meet back up at this point. So we must have a current of 5 amps flowing along this branch here and there, and then here again when the current meets back up. And that means that the currents along each of these branches must total 5 amps. So if we know that this is 1 amp, then the 5 amps of current here splitting into 1 amp here must split into 4 amps here as well. So we have 4.0 amps is the reading on A5, and if this is 5 amps here, splitting again into 2 amps this time and 3 amps for A3, then if we look at the table we have 3 amps and 4 amps, so we must have an answer of D. Question 4 says two resistors are connected as shown. So we've got two resistors in parallel between terminals P and Q, and it's an 8 ohm resistor and a 24 ohm resistor. Then says the total resistance between P and Q is. So remember, to do this you need to use the relationship for resistors in parallel. So we have 1 over RT equals 1 over R1 plus 1 over R2. Subbing in the numbers gives us 1 over 8 plus 1 over 24. So we can then use our calculator to do the brackets method or the x to the minus 1 method, or you could choose the lowest common denominator method without using a calculator. So if I was to use the lowest common denominator method here, then I could say, okay, 8 goes into 24, so I'm going to leave the 24 and say that 8 goes into 24 3 times, because 3 8s are 24. So that means I can multiply the top and bottom of this fraction by 3. So that gives me 3 over 24 plus 1 over 24 is 4 over 24. And then if I flip both sides to get RT on its own, I get RT equals 24 over 4, and that gives an answer of 6 ohms. So my final answer is C. Question 5 says a block has the dimensions shown. So we've got a length of 0.2 meters, a width of 0.05 meters, and a height of 0.1 meters. It then says the block is placed so that one of the surfaces is in contact with a smooth tabletop. The weight of the block is 4.9 newtons. The minimum pressure exerted by the block on the tabletop is... Well, remember the way that pressure is related to area in that it's sort of an inverse relationship. So the bigger the area, the smaller the pressure, or the smaller the area, the bigger the pressure. So if we want to find the minimum pressure exerted by the block based on one of its sides, then we need to choose the side with maximum area. So the maximum area side will be taking the biggest numbers here, 0.2 times the 0.1. So that's going to be area 0.2 times 0.1, which is 0.02 meters squared. So we've got our area. We know the force is given by the weight of the block here, which is 4.9 newtons. So for the minimum pressure, we have P equals F over A. Substituting in the numbers gives 4.90 over 0.02. Putting that into your calculator gives a final answer of 245 pascals, which gives an answer of B. Question 6 says that a syringe is connected to a pressure meter as shown. The syringe contains a fixed mass of air of volume 150 millimeters cubed. The reading on the pressure meter is 120 kilopascals. The volume of air inside the syringe is now changed to 100 millimeters cubed. The temperature of the air inside the syringe remains constant. The reading on the pressure meter is now... So notice here that we're dealing with volume and pressure changing and temperature is remaining constant. So this question is to do with Boyle's law, i.e. the pressure volume law. And we're asked to find the new pressure. So we need to use Boyle's law, which is P1V1 equals P2V2. Sub in the numbers to find P2. So we have 120 times 10 to the 3 for P1, which is the 120 kilopascals converted into pascals, times the 150 for the millimeters cubed, is equal to P2 times the 100 millimeters cubed. And we can then do the left-hand side in your calculator and then divide it by 100 to get P2 on its own, which gives an answer of P2 equals 1.8 times 10 to the 5 pascals, or in other words 180,000 pascals, which is the same as 180 kilopascals. So this gives an answer of C. Question 7 says a sample of an ideal gas is enclosed in a sealed container. Which graph shows how the pressure P of the gas varies with the temperature T of the gas? Well, remember the relationship between pressure and temperature is to do with Gay-Lussac's law, i.e. the pressure-temperature law. And remember this says that for a fixed mass of gas at constant volume, pressure and temperature are directly proportional. However, this only holds, remember, when temperature is measured in Kelvin. So E would be the correct graph. However, notice that temperature is measured in degrees Celsius there, not in Kelvin. So that is not going to be my answer here. If that was in Kelvin, then that would be a correct graph. However, if you've seen my theory videos on Gay-Lussac's law and Gay-Lussac's law experiment, you'll remember that we plot a graph of pressure against temperature in degrees Celsius, and then we plot a second graph which shows us the pressure against temperature in Kelvin. So the first graph was actually pressure against temperature in degrees Celsius, and it looked like this one here, where we got a sort of sloping up positive gradient line, but it wasn't going through the origin. So this is actually a correct graph for this relationship of pressure against temperature. And remember, if we were to extend this back to cut through the x-axis, it would actually cross at 0 Kelvin, i.e. give us a graph like this, but with temperature in Kelvin. So the correct answer here has got to be A. Question 8 says that a student makes the following statements about waves. So statement 1 says waves transfer energy, statement 2 says a wave with a short wavelength diffracts more than a wave with a long wavelength, and statement 3 the amplitude of a wave depends on its wavelength. Which of these statements is or are correct? Well, let's look through each statement and decide whether each one is true or false. So statement 1, waves transfer energy. Well, first of all, that is true. That's one of the first things that we learn in the waves topic, that waves transfer energy. Statement 2, a wave with a short wavelength diffracts more than a wave with a long wavelength. Well, that's false, and the reason for that is to do with the rule relating diffraction and wavelength. So remember, longer wavelengths will diffract more than shorter wavelengths, and that's just something you need to remember. Lastly, the amplitude of a wave depends on its wavelength. Well, that is false, and the reason is that amplitude is half the vertical height of the wave, remember, and wavelength is to do with the horizontal distance or length of one wave. So if one's vertical and one's horizontal, then they're completely independent of each other. They don't relate in any way. So the amplitude does not depend on wavelength. So that means we have statement 1 is the only one that's correct here, which gives an answer of A. Question 9 says the diagram represents a wave. The wavelength of the wave is the horizontal distance between points P and Q, P and S, Q and R and S, or S and T. Well, remember in general terms, wavelength is defined as the horizontal distance from one point in a wave to the same point on the next wave. So if we think about P and Q, for example, that is not one wavelength along, that's about 3/4 of the wave along. If we look at Q and R, that is only half a wave because we've gone from down to up here. And R and S, that is 1/4 of a wavelength. But then we've got S and T, which is actually a full wavelength apart because we've got all the way down, all the way up, and back to the start. So S and T is going to be our answer here for one wavelength. So our answer is E. Question 10 says that the diagram represents the position of the crests of waves 3 seconds after a stone is thrown into a pool of still water. You've got the centre here, and then you've got evenly spaced crests which are 1 metre apart, and the total distance from this point to this point is 6 metres. It then says which row in the table shows the speed and the frequency of the waves. Well, this involves a bit of thinking ahead, because if we can work out the frequency first of all, then we can use the frequency in an equation for the speed of a wave, v equals f lambda, in order to find the speed of the wave. So if we can find the frequency first, we can then find the speed. So to find the frequency first of all, we can use f equals n over t, which is the frequency equals the number of waves over the time. So we've got a time of 3 seconds, and we've got the number of waves here being 1, 2, 3 waves in this time. Because remember, these circles represent the crest of a wave. So if I'm going from the middle to the crest here, that's one wave. If I'm going from the crest to crest here, that's another wave. And going from here to here, that's another wave. So that's 3 waves in 3 seconds. So I have 3 divided by 3, which gives me 1 hertz. So that means my answer is going to be B or C here. But now I can use my frequency in the equation for speed. So I have v equals f lambda, which equals 1 times 1.0, because that is my wavelength going from crest to crest, the top point of one wave to the top point of the next wave. So that's 1 times 1, which gives me 1 meters per second. So that means my final answer is 1.0 and 1, which is C. Question 11 says a ray of red light passes through a double glazed window. Which diagram shows the path of the ray as it passes through the window? Well, to answer this, we need to remember 2 key things, which is that when light goes from a less dense material like air into a more dense material like glass, it's going to bend towards the normal, whereas the opposite is also true. So when light goes from a more dense material like glass into a less dense material like air, it's going to bend away from the normal. So we have that light going from air to glass bends towards the normal, and light going from glass to air bends away from the normal. So we need to work out which of these diagrams is actually showing us that. So if we look at diagram A first of all, if we think about where our normal would be here, it's going to be at 90 degrees to this surface along in this direction. So we can see that the light coming in would actually bend towards the normal, which is in the middle. So if my normal was along here, it's coming in and it's bending towards the normal. And then when it leaves the glass, it's bending away from the normal, which would be at this point here. It's then going back into the glass here, again bending towards the normal, and then bending away from the normal. So it looks like A is going to be our correct answer here. Let's just look at the others to make sure we can eliminate those. So for B, we would have our normal along here, and the light is coming in, and then it's bending away from the normal, so it's not bending towards the normal here. And then as it leaves, it's bending towards the normal, which would be along here. So that is incorrect. For C, we've got the light coming in and then bending towards the normal, but then it also bends again towards the normal when it leaves the glass. So that has got to be incorrect. For D, we have the light coming in, and if this was my normal, the light is actually passing along the normal, but that's not going to happen. So that is also going to be incorrect. And for E, again, we've got the light bending away from the normal at this point here. So it's bending down the way. So our answer has got to be A. Question 12 says, which row in the table shows how the mass and charge of an alpha particle compares to the mass and charge of a beta particle? Well, remember, an alpha particle has a larger mass than a beta particle, and in fact the alpha particle has the largest mass out of alpha, beta and gamma. So it's going to have a larger mass, so it's going to be A or B. And remember, the charge in an alpha particle is positive because it's got 2 protons and 2 neutrons, so the 2 protons give it a positive charge, whereas the charge in a beta particle, which is an electron, is a negative charge. So they're going to have opposite charge. So that means my answer is going to be B. Question 13 says, during ionization, an atom becomes a positive ion. Which of the following has been removed from the atom? Well, if an atom has become a positive ion, then that means it's lost an electron through the definition of ionization. So that means our answer is B. Question 14 says, which of the following is a vector quantity? So remember, a vector quantity has both a magnitude, i.e. a size, and a direction. So which of these 5 variables needs a direction? Well, it's going to be not mass, not time, not speed, not kinetic energy, but acceleration. So our answer has got to be acceleration, because we care about direction when we define accelerations. Question 15 says that a ball moves along a horizontal frictionless surface and down a slope as shown. So we've got 2 points P and Q, and it says which of the following graphs shows how the speed of the ball varies with time as it travels from P to Q. Well, the ball is going to travel with a constant velocity until it reaches this point here, at which point it's going to be travelling downhill. So it's going to gain kinetic energy because its gravitational potential energy at this point is going to change into kinetic energy. So it's going to gain speed as it moves through Q. So we can show a gain in speed, i.e. an acceleration, with an upward sloping line on a graph. So we have a constant velocity and then an acceleration. And the only graph which shows that is going to be graph D. So we've got a constant velocity until we reach this point here, and then we get an acceleration and increase in speed as it rolls downhill. The reason it's not A is because that's a constant velocity and then a deceleration, i.e. it's slowing down, but that's not going to be the case. For this one, we have an acceleration followed by a constant speed, but that's not going to happen. For C, we have a deceleration and then a constant speed, but again, that's not going to be the case. And for E, we have an acceleration followed by an acceleration at a smaller rate. Moving on to question 16, a cyclist is travelling at 10 meters per second along a level road. The cyclist applies the brakes and comes to rest in a time of 5 seconds. The combined mass of the cycle and cyclist is 80 kilograms. The maximum energy converted to heat by the brakes is... Well, if we think about this, first of all, the heat is going to be produced at the end, but we must have some energy at the start to be converted into that heat. And the energy at the start is going to be due to kinetic energy because the cyclist is coming to rest, they're coming to a stop. So we could say that by conservation of energy, the work done EW by the brakes to produce heat is going to equal the change in kinetic energy to bring the cyclist to a stop. So we could say this change in kinetic energy is simply equal to the kinetic energy expression a half mv squared because the final velocity would be 0. So we're looking at the initial kinetic energy here and the final kinetic energy would be 0. So we don't have to take that into account here. So this is equal to a half times the mass of 80 kilograms times the speed of 10 squared. Putting that into your calculator should give you an answer of 4,000 joules. And that is the answer of D here. Question 17 says that a rocket is taking off from the surface of the Earth. The rocket engines exert a force on the exhaust gases. Which of the following is the reaction to this force? So this is a Newton's third law question, or in other words, a Newton pair. So remember, for Newton pairs, we basically just take the action sentence and we swap the words round to get the reaction. So if the rocket engines exert a force on the exhaust gases, then if we swap the rocket engines and the exhaust gases round, then we get the exhaust gases exert a force on the rocket engines, which is the option E here. So the force of the exhaust gases on the rocket engines. Question 18 says that a ball is projected horizontally with a velocity of 1.5 meters per second from a cliff as shown. So there's your half a parabola shape. The ball hits the ground 1.2 seconds after it leaves the cliff. The effects of air resistance are negligible. Which row in the table shows the horizontal velocity and vertical velocity of the ball just before it hits the ground? Well, if we think about the horizontal motion first of all, if we know the initial horizontal velocity u is 1.5 meters per second, then we could say the final horizontal velocity of the ball just before it hits the ground is going to be the exact same, 1.5 meters per second. The reason for that, remember, comes from the definition of the projectile, which is that a projectile has a constant horizontal velocity and a constant vertical acceleration. So the constant horizontal velocity means that it's going to stay the same, so 1.5 meters per second, which means our answer will be C or D. For the vertical motion, however, the initial velocity is 0 meters per second because when the object is projected horizontally to begin with, it's not started travelling vertically yet. And we can say the acceleration A is equal to V minus U over T, and subbing in the numbers we get 9.8 meters per second squared for the acceleration due to gravity is equal to the final vertical velocity V minus 0, which we just said up here, divided by the 1.2 seconds for the projectile to hit the ground. So if we cross multiply here, 9.8 times 1.2 gives us V, which is 11.76 meters per second, which we could round to about 12 meters per second. So this gives us 1.5 and 12, which is an answer of C. Question 19 says that the minimum amount of energy required to change 0.5 kilograms of water at its boiling point into steam at the same temperature is. So here we're talking about specific latent heat, and specifically it's to do with vaporization because we're dealing with boiling water. So we're dealing with specific latent heat of vaporization, and we've got the mass of the water. So we want to find the minimum amount of energy, so we need to use the relationship for specific latent heat. So we have EH equals ml, where L is going to be L subscript V, in other words the latent heat of vaporization. So substituting in the numbers gives us 0.5 times 22.6 times 10 to the 5, which is the latent heat of vaporization of water from the data sheet, and putting that into your calculator should give you an answer of 1.13 times 10 to the 6 joules, and you'll see that that is an answer of D. Lastly, question 20 says that a student makes the following statements about the universe. Statement 1, the Big Bang Theory is a theory about the origin of the universe. Statement 2, the universe is approximately 14 million years old. And statement 3, the universe is expanding. Which of these statements is or are correct? Well, let's go through each statement in turn and decide which ones are true and which ones are false. So the first one, the Big Bang Theory is a theory about the origin of the universe. That is true. So it's an effort to explain what happened at the start of the universe, how the universe came to be. And statement 2, the universe is approximately 14 million years old. That is false because it's not almost 14 million years old, it's almost 14 billion years old. So to be more precise, it's about 13.8 billion years old, or 13.8 times 10 to the 9 years old. So they've tried to trick you here with the million. And lastly, the universe is expanding, and this is also true. So there's lots of evidence to support this, and you'll learn more about this in higher physics. But remember, we've got things like redshift and Hubble's law which support this statement. So this means we've got 1 and 3 that are correct, which gives an answer of D. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.